Fresh water is extremely important on Earth. Only 3% of our water is actually in the form of fresh water. And only a fraction of that is actually usable fresh water on the surface.
If we don't know what kind of freshwater availability we have, then we may have issues in terms of droughts. We might have landslides, floods, and things like that. And we need to be able to track this long term.
So understanding how fresh water moves through the system is extremely important, both at the local scale, looking at how much water we have in our reservoir, to the larger scale, looking at how precipitation moves from ice pack to the ocean and then is evaporated from there. Sensors on the ground can look at a point source, so we understand how much rain is falling at a specific location. But there aren't very many gauges around the world that can provide that information for us.
If we were to take all the existing rain gauges in the world, they would fit into an area of about the size of 2 basketball courts.
So what satellites enable us to do is provide a much more global picture of the rain that we observe.
GPM is an international satellite mission that will set a new standard for precipitation measurement from space, providing a new generation of observations of rain and snow in all parts of the world every 3 hours. The GPM mission consists of a constellation of 9 satellites, provided by a consortium of partners in the United States, Japan, France, India, and Europe. The GPM constellation is united by a common reference satellite known as the GPM Core Observatory, provided by NASA and JAXA.
GPM is one of the largest spacecraft we've ever built here at Goddard. It's about 13 meters by 6.5 meters by 5 meters. That's about the wingspan tip to tip of a small corporate jet and about the same weight, but only 1/3 as long. In the particular case of GPM, we are a follow-on mission to the Tropical Rainfall Measuring Mission, which was launched in 1997. So part of what GPM was supposed to do was just continue those measurements. But also GPM is to improve those measurements by being able to, for example, measure finer precipitation.
The more channels you have within one instrument, then you can cover a wide spectrum of a precipitation products, all the way from rain to ice.
The GPM core has an active radar and a passive radiometer, and these 2 instruments are just like what a doctor might use in terms of an X-ray for the radiometer and a CAT scan for the radar to diagnose what's happening in clouds and to understand what's happening with the precipitation.
The data collected by the GPM Core Observatory will provide a unique data set that will allow us to translate satellite measurements into the rain or snow that hits the ground anywhere on the globe.